Welcome to Coming Clean, the podcast dedicated to common sense environmental dialogue, environmental optimism, and real environmental solutions. This show is proudly powered by Ørsted.
Welcome to the Coming Clean podcast. I'm your host, Stephen Perkins. In this episode, we continue our dive into the logistics of the clean energy transition. And today, it's about how to store clean energy, something that is one of the trickiest hurdles to overcome. Hydrostor is a Canadian-based company working to make it less of a headache, and their Executive Vice President of Global Policy and Regulatory Affairs, Scott Bolton, is here to help walk us through their unique approach. Scott, welcome to the podcast. Thank you so much for coming on.
Thanks for having me. It's great to be here.
For sure. We're happy to have you and really interested about the work that Hydrostor does. But before we get to that, before we get to talking about your organization, I really want to hear about you and your background and what led you to the role that you're in today as the Executive Vice President of Global Policy and Regulatory Affairs. How did you get to that point?
Yeah, thanks. It's been a little bit of a journey. I spent just under 20 years working in the electric utility industry. So I work for a company called SimCorp, and they are a electricity provider across 6 Western states, Oregon, Washington, California, Utah, Idaho, Wyoming. And I had a great career there. I had the opportunity to work in public policy and with customers and really during a time that we've seen a lot of new technology and transition in the electricity sector. So I was there during our acquisition by Berkshire Hathaway Energy. So being able to be part of one of the largest and most expansive, utility owners in not just America, but I think across the globe. So that was fantastic. But one of the things that I witnessed over my career there is as new technologies started to evolve and go from idea to commercialization, that wasn't always a smooth transition. There was always a lot of, kind of with any new product or any concept that comes into a very well-established industry, there's some growing pains. And so I've kind of come to the point in my career where I see energy storage as really that next technology evolution in how we create, heat, and deliver electricity. And at a time when electrification is growing, the amount of reliance that our economy and all of us as individual citizens have on the availability of electricity. And as I saw this new technology starting to really get closer and closer to deployment, thought, I can help bridge that. I can help be in a position to make that a smoother transition. And that's one of the things that, really helped motivate me to kind of switch hats and come over to the technology and development side and really take advantage of what I think is going to be a really exciting time in this space.
It is an exciting time in the energy industry in general. And I know I talk with a lot of high schoolers and college students who want to get into this space, and there's almost overwhelm of which direction do I go into. But I also find it interesting that high school and college students are interested in the energy industry. So can we actually go a little bit further back in your history? What was it that got you into the industry? Were you really excited about, about utilities as a kid, or like, how did that interest evolve?
Yeah, no, not at all. Not at all. Like I said, I've been in the in the utility side of the industry now for almost 20 years. And if you'd asked me 21 years ago, did I imagine much of a career in utilities? I would have said absolutely not. That utilities are where creativity goes to die. But going further back in my background, after high school, before college, I joined the military. I served in the Army. And that was a fantastic experience to not just learn new skills, but really how to think and problem solve and, embrace leadership through different models. And at the time that I entered the electricity sector, it was at a point where the West Coast energy crisis had just occurred, the bankruptcy of Enron and a number of other energy marketers and innovators in the marketplace, had kind of blown up, and trust was really low, and you know clearly the sector seemed ready for a new wave of thinking and leadership to enter into the sector. And so that was a time when I was recruited to come learn uh, the utility business, come and learn the role, electricity and as a regulated business, what that means for uh, the local economy. And that was what brought me in. It was the opportunity to kind of help rebuild some trust and offer some fresh perspectives into a space that hadn't really had quite as much around that time. And so that happened to coincide very well with a real revolution in renewable energy and new systems and innovations within that sector. And so really had the opportunity to kind of tinker with that.
So talking about Hydrostor, a company that based in Canada but does work across the Americas, and some really interesting projects that I'm not going to pretend to fully understand, but that's what this episode is about, to learn more about that. Tell us about what y'all do and kind of the history and where you're playing currently.
Yeah, you bet. So maybe a little bit about the company. So Hydrostor has been around for over a decade now, but still growing to scale. It's a global leader in what we call advanced compressed air energy storage. So ACASE is the kind of shorthanded acronym that we use to describe the technology. And uh, Hydrostor has a pretty uh, you know leading deep position within this particular technology. So compressed air energy storage is a proven technology. It's been around for a while. There's a plant in Germany that uses compressed air, so heated air, to store the energy from waste heat and then be able to be utilized again to make electricity. There's also a plant in Alabama, but historically they've been fairly small scale. They've been reliant on fossil fuel to kind of fire and to primarily create that energy in the first place, to then be stored, and have been difficult to really scale up. What Hydrostor has been able to do is take that concept of compressed air, but through a very innovative design, be able to use, as I like to describe it, gravity and water through the use of creating um, uh, big storage cavern in the ground, which is where we keep the compressed air, and then using hydrostatic pressure from water in a reservoir above ground, be able to hold that air in place, and then when it's time to move that air back out through a generator, release that reservoir into the cavern, push the air up, and create electricity, and do so at quite a large scale. So, we're talking hundreds of megawatts of capacity and a duration of constant discharge or energy back to the grid of 8 hours or more. So, I would say uh, there's a lot of complex science and engineering behind that, but the concept is actually fairly simple. Any of us that have needed to put air in our tire, you've got an air compressor, you plug it into the wall. That plug into the wall is basically how we charge our system. We use energy from the grid, usually when it's paired up with renewable energy. When there's surplus or low cost energy on the grid, we would use that through the extension cord or transmission line into our plant. Um, Much like an air compressor, we fill that canister with air through, compression technology. Um, and instead of, a big metal canister, that's our cavern underground. And then, when it's time to fill that tire, when the market needs that electricity, we're able to do that and reverse the process back. So we have projects underway that are in advanced permitting in California as well as Australia. In fact, it's highly likely our Australia project will be the first major advanced compressed air energy storage, project online in the world, and will likely be one of the largest long duration energy storage facilities on the planet when it goes into service. And then as we look at a technology that I really believe is about to really burst out onto the scene, I think, over the next few years, we'll be, likely announcing other project developments as well.
I love the little teaser for what might be coming next. So I was going to ask you to explain it like we're five, and I think that's a good, that analogy they use is good. So basically, we're taking energy off the grid, we're compressing this air underground, and then when we need it, we're releasing the air, and that sort of whatever science term you want to use there, but that compressed air generates the electricity, basically releasing it back onto the grid. Is that did I get that right?
You got it right. And what I maybe should have elaborated on is why. you
Yeah.
know, what problem does this solve? And our mission is that this is one of the biggest problems to solve. So we've seen the real growth of renewable energy, solar, wind energy, even some hydro that, may be run to the river or not as dispatchable as other systems. And so what we have right now in the US is the penetration into the grid of a lot of low cost renewable resources, but we don't have the ability to control when that electricity is optimally made and when it's not. And so we really do have a situation where we can have certain times of the day or year where the grid is producing more energy than can be consumed. Demand isn't keeping up with that supply. And right now, it basically gets wasted. You have to curtail or turn off some of those resources to make sure that you're always in perfect harmony between supply and demand. And then, you have some times of the day where demand outstrips supply. And energy storage, and in particular, long duration storage that can bridge across nighttime, that can bridge between days of, high wind and no wind. That's the solution. That is how you integrate and smooth out that energy production and that ability to meet electricity demand by customers. So that's the premise, and that's really the niche that this technology fills and the problem that we solve.
Yeah, I think what a lot of people don't always realize is that where renewable energy tends to be produced or captured is typically very far away from where people live. So I think here, where I am in Texas, up in the Panhandle, we have the enormous, fields of wind turbines. We've got solar out in the West Texas desert. But when you're trying to get that to the people in Houston, Dallas, San Antonio, there's a lot of transmission that hasn't been built yet. To your point, there isn't storage that can happen along the way. We traditionally think of battery storage as kind of the traditional storage model that we talk about. Where, relative to production and consumers, does Hydrostor develop your sites?
It's a great question. We are geology dependent. So we have quite a bit of flexibility in how we can site our plants. Unlike other long duration storage technologies, such as pumped hydro storage, which is basically having two reservoirs shifting water back and forth to make electricity. We have a little bit more flexibility in how we can site. So it could be near where generation resources are, so where the wind and solar are at. that's potentially a good place to locate a storage system. But we can also site our projects closer to loads as well. And the typical footprint, so how much of the plant you see above ground is generally around the same size as a natural gas power plant. So definitely an industrial, site, lots of piping and metal and machinery within that fence line. But what really matters most to us is our ability to connect to the transmission system and the quality of the rock below. And generally, particularly in North America, we have some pretty good rock quality. Of course, we have to do the geotechnical surveys. We have to know that for sure before we site a project. But what's nice is that we're not creating a new process. We're not doing something that there isn't a great labor force and skill base for here in America already. We're using the same technologies as traditional mining, as the natural gas industry, and creating storage facilities for hydrocarbons, so for natural gas and oil. So we can use a lot of the same labor profile that has served those other parts of the energy industry and apply them to our technology as well.
One of the first thing that comes to mind, I'd be remiss if I didn't ask, the environmental impact of a site like this. So you're creating essentially a big hole in the ground. I imagine there's some things there. Another question of that is, are you reinforcing that with cement? Is it sort of, what does that look like underground? And then also, what are the potential challenges with having compressed air stored underground? If you could just take us through some of those pieces.
Yeah, you bet. So yeah, of course, like with any major excavation or mining activity, that will be highly regulated for safety and environmental impact. And again, the nice thing is that our technology and what we do to create our storage caverns doesn't require new regulations or laws. These are well established practices. So being able to follow existing design and safety requirements for that cavern construction is really helpful. We're kind of leaning on the accomplishments of our energy forefathers and being able to utilize the same labor and the same environmental and regulatory screens. Yes, so part of the design is to make sure that we can store air and safely and make sure that it doesn't go anywhere. It stays within the cavern, as well as the water that will flow back and forth. And so we will improve that cavern. We will line it with different materials. It could be cement, it could be different polymers. It's going to be pretty specific to what that rock quality is and the design of each project's cavern. But again, kind of existing uh, practices to help guide how we would do that. And then when you talk about the use of resources, the rock that we take out, the waste rock, that can be used for all kinds of secondary purposes. So aggregate for road building or for cement or for other industrial uses. Suddenly we have a byproduct of our process that can contribute to a secondary economic benefit. Water use, which I've mentioned, we do rely on water, but unlike hydroelectric power or other pump storage technologies, we don't need as much. And so we are going to the Federal Energy Regulatory Commission for licenses to operate these facilities. They basically use water much like other industrial processes. So it's a relatively smaller footprint than other infrastructure-based storage technologies. It's lighter touch on water and our underground activity is really just moving air back and forth. So it's not like storing natural gas or other gases where if somehow we are no longer in containment, we've created an environmental problem.
So, what are the issues that you run into at development? Whether they are regulatory issues, maybe it's you talked a little bit about site selection, very dependent on the geology of the space, talent to get these things developed and executed. What are some of those roadblocks that y'all experience?
Yeah, so admittedly, I think a lot of these we will discover as we go. I feel like um, we'll have a little bit more detail on how to answer that question as we get further along and develop more projects. But I think out of the gate, we're like any other major infrastructure project. We're going to have community impacts. We're going to have different stakeholders that are going to weigh in, whether it's NEPA and environmental permitting, or it's even just making sure we've got the right zoning for where we're putting in a project. We're going to go through the same hoops as any other industrial project. The biggest barriers right now, or the biggest challenges to overcome, is really connection to the transmission grid. Part of our use case is that we can help take some of the pressure and congestion off of the transmission system by being able to store energy. So we're actually part of the solution, but in order to be part of the solution, we've got to be able to get hooked up in the first place. So it really is getting that interconnection to the grid that any energy player has to grapple with. And then, the other is just commercial adaptation. So getting customers lined up, educating and getting utility companies comfortable with the technology and helping them understand how our energy storage solution, can complement how they run the grid reliably, and how this can become an affordable solution for them. So those really are what we're encountering right now.
When you
I'm
talk
sure that
about
there will be. Yeah, sorry.
No, you're good. But when you talk about connection to current transmission, that's something that we talk about at ACC a lot. Transmission, with renewable, as I was saying, with them being further out from where populations live, building that transmission network is going to be really important, right? To literally power the energy, the clean energy transition. What does that look like when you're trying to connect up to it? Is that when you run into challenges? Is that because governments or states aren't building those out? It's because you have to, as a company, you're building those out, and it's hard to do that. Kind of take us in for someone who isn't aware of how connection to transmission works. How y'all work through
Yeah,
that.
and I'll probably lean more here on my previous life working at Pacific Corp, which is the largest private transmission owner in the Western U.S., and that was part of my portfolio before I came here about Hydrostor. And a lot of the transmission system that the country relies on today, was really built 30, 40 years ago. It was really the last big tranche of transmission build. And a lot of development and growth occurs. And so where there may have been a transmission line out in the middle of nowhere, may be somebody's community today. And so um, that interface between the public and, the bulk electric transmission system, has just become more challenging over time as, you know, communities and economies grow. On top of that, it's just really expensive. The transmission system provides enormous benefit, and it's probably one of the least understood components of our broader energy system. But it is an expensive piece with a lot of planning that goes into it, as well as just regulatory consideration and approvals. Um, I used to quip quite a bit in my old job that any new transmission line that's conceived up today will be old enough to go to college by the time it gets built. It will take at least a decade for most major new transmission lines to be planned and built, and oftentimes, much longer than that. And that slowness of additional new transmission is just really at odds with the growth and demand being placed on the system for new energy resources. So there may be some opportunities to repower existing power plants or to replace existing power plants and where they connect into the, the transmission system with new technologies. But the reality is that America and the globe's reliance on electricity is really growing, and it's outstripping the ability to keep up on an infrastructure basis. And that's really the fundamental pressure that's on the transmission grid right now, or transmission system. We think our advanced compressed air energy storage technology and long duration storage in general really helps with that. We can use the existing transmission more efficiently. We can integrate these new intermittent renewable resources more holistically. We've got a huge role to play in stretching the value of the existing infrastructure that we have in place. But without a doubt, everybody needs just more connectivity and more ability and capacity to put energy online, because the need on the consumer end is just growing that much more.
I imagine a big piece there is the education of people about what this is, why it's important, why long term it can lead to cheaper, more reliable energy. And what I have observed, and I'm not saying this is the case for y'all, but what I've observed from my seat, working and talking to industry and energy companies, is they're so intelligent when it comes to the storytelling and the marketing and the education that they are not, right? And so it becomes this huge problem where you have this great idea, you have this innovation, but getting the public to care about it, to pay attention to it, to understand it with shorter and shorter attention spans today becomes a real challenge. Uh, how do y'all think about education? How do you begin to engage some of the communities you work in, and how do you get people to understand everything that you're trying to do?
I mean, it's a great question. It's a question that frankly should be asked and answered of every participant in the modern energy system, because we have to be thinking in those terms. And for me, it really is, how do you meet the public where they're at? Because there is no one perspective or paradigm that you're addressing. We're a diverse nation with lots of different sizes and shapes of communities and different perspectives, along the spectrum. And so I think a lot of it is being very transparent and having real authenticity behind what you're trying to do. No matter who you are, you can kind of, smell a snake oil salesman coming down the road. And so I think, the energy sector and certainly my company have to step up, and we're dedicated to stepping up and just being very clear what our technology does, why it's important, what the big picture issues are that we're solving. We're not just here to build stuff, and spend a lot of capital without really having a strong need case behind it. And I do see the public getting more sophisticated around their energy use. Certainly, over my career, you know, 20 years ago, there was not much of a debate of, what's the carbon content of my energy use? What is my, every time I flip on a switch, what is my contribution to the emissions picture? We see that now. I saw it at the utility, and I see that now in the clean energy and clean tech space. So it is a more sophisticated consumer who's paying attention to their energy use, but you're always going to have those very localized impacts and interfaces, and you've got to be willing to come and meet people on their doorstep and explain what you're doing and answer their questions to have any real credibility to go from an idea to a reality with a project of these scale and scope.
With that, do you encounter a lot of NIMBYism whenever you're in a community? Is that a big part of the struggles that you face?
So far, we've been doing pretty well on that level. We just completed our environmental impact statement process, or near completion, in Australia around a project, and very limited feedback from the public. And I think that speaks to having a very strong upfront ground game of going into communities and explaining what we're doing on the front end, making sure that people aren't kind of finding out late in the process that there's a big new neighbor next door. And so I think we're definitely going to learn from and apply these lessons as we go. Our project in California, we've had great engagement with the local county officials and other stakeholders in that community, who again, especially in rural communities, I think they don't get enough credit for that. They bring real experience. These communities have provided important contributions to the natural resource economy of the U.S. for many years. And so I think any developer who goes in not understanding that, yeah, there might be some concern, there may even be some level of NIMBYism, but they're the folks who live there. And if we can't establish that we're going to be a net contributor and a good neighbor, then we probably don't belong there. So it's easy to complain about process and get frustrated. I mean, Lord knows energy development is about having good days and bad days and persevering through those. But that persistence and that constant engagement and willingness to really listen is the only way anything can get done.
But I think that's an important point about the rural communities, and certainly one that I feel strongly about is sometimes developers will think these are going to be easier places for us to do this in because they don't quite have the resources to fight back. They probably don't have as much of a of an opinion or as much of a bandwidth for a say. But to your point, they're some of the most connected to their earth and to their environments, and so I think that's important that y'all involve them heavily in that process. Um, okay, so maybe not as much NIMBYism, but for your critics, what do your critics say, and what do you say back to them if you were to grab a coffee with the people who are against your projects? What are they telling you, and what are your responses to them?
Yeah, I'm gonna invent some of those here because I just haven't had enough real world experience with uh, you know an intractable stakeholder problem. But I do think energy projects writ large, do have critics, and I think they fall largely into a couple categories. One is just need. Coming out of the utility industry, big complex systems that ultimately most consumers, most customers, ratepayers see at the end of the day is what's on their bill. And so, I'm not sure most people who go about living their life and has a real dependence and reliance on electricity and natural gas to light and heat their homes, really have to think very far upstream about how that's being done and how their providers are investing to serve their needs today and out into the future. But they do notice when their bills change. And so whether you're on the development side or you're a utility service company, bringing that service down to the community, to the household level, anytime there's going to be a new technology or a new major infrastructure project, that will have some level of impact on customer bills. And so there's always going to be a heavy scrutiny on whether that is the right solution, whether that's the right cost, and whether the right people are bearing that cost. And so that will always be there. I fully expect it to be, part of the conversation as we, develop our systems and, engage utilities and other customers in deploying those systems. So, it is incumbent on us to not only, be very compelling that we solve a real problem and we solve that problem at a scale and at a cost point that is a net benefit for consumers, that customers will be better off with investment in energy storage than, if other solutions were brought or if no solution was brought and their costs go up anyhow or their electricity is less reliable. So I do think that economic need will always be part of the picture. And then there's going to be is this the right facility in the right place, as we were talking about. And I think on both levels, those problems can be solvable.
One of the criticisms that I often hear just about new energy technologies in general is we are decades off from this being commercially viable. The technology is not where it needs to be for this to scale. We hear this a lot with nuclear, right? The critics of nuclear will say, well, the regulatory framework and the technology is just probably 10, 20 years off. And so we shouldn't, invest too heavily in that. My response to that is we're a country that has in the past moved very quickly on things that have been beneficial. So I don't buy this idea that because today it's 10 years off, that tomorrow it has to be 10 years off. I think we have shown our ability to innovate very quickly, but also not investing today in what could have a major, compounding impact on the climate challenge that we find ourselves in seems like a miscalculation. Do you encounter that with critics? I mean, do you hear people say this is a great technology, but the scaling ability is a long ways off? And so, how do you think about that?
Yeah, that's a great way to frame it. If everything's 10 years off, it never arrives.
Yeah.
You've got to take some risk and you've got to, push through and innovate. And that's really the stage that we're at right now in Hydrostor's journey. Our Willow Rock project in California, our Silver City project in Australia, these are going to be large scale, grid connected. These are demonstration projects. These are real solutions that will become a solution on day one of their operation. And they're within a few years of becoming operational. And so as we demonstrate the viability of the technology, the safety and operational capabilities of what we're talking about, that adoption will grow from there. I'm fully confident in that, as are our investors that have stood behind the company and really believe that this is going to be a really important contribution to the overall, not just energy reliability picture, but as you mentioned, decarbonization as well. I also think one of the interesting features to our advanced compressed air energy storage technology and systems is that, it's a new application for energy storage, but we're using existing parts and practices. So as I mentioned earlier, we're using the same workforce and technologies for creating our air storage caverns as the mining industries and the natural gas storage sector currently employ today. So even if you believe that the grid is going to become less fossil fuel dependent, the jobs that are currently feeding into that sector today have a home with our technology. As well, when I talk about the air compression systems, heat exchangers, and the generation technology to send electricity back to the grid, these are not new. Need to figure out a manufacturing process to make these systems. They already exist today. the ability to spin a turbine and generate electricity, that's a fairly off the shelf technology right now. And the other components to our air compression system can be found in other industrial uses in manufacturing. So the secret of our sauce really is reassembling existing supply chains and equipment to do different things and to do it cleaner and better.
That's important both from a timeline perspective, but also in a previous episode, we talked about the importance of talent in the energy transition and people who, over time, their jobs are at risk. Their jobs are, going to become maybe even obsolete. It sounds like, and correct me if I'm wrong, but you're able to take people who were previously in the natural gas space or previously in all these other energy producer spaces that have those skills and put them into one of these facilities, and maybe with a little bit of retraining, but you're able to provide jobs to people who come from those industries. Is that right?
Absolutely. It's not only a speed to market consideration for Hydrostor, but it really is, I think, a great story that's probably not well enough understood within the idea of an energy transition. That um, we're able to leverage the existing talent pool that America has relied upon to provide its energy needs for decades into a new application, and it's one that, again, not a ton of differentiation. We're doing much of the same kinds of basic things, but we're just doing it differently, and we're doing it in a way that brings the component parts of both new and old pieces of the energy mix together to be more efficient and to ultimately be much more clean.
I love it. And I encourage people to check out the website. There is a video there that does a good job of explaining how there kind of includes a cross section, how the technology works, and all of that. I want to end, Scott, with a couple of rapid fire questions. They really don't have a ton to do about Hydrostor, but just to kind of get some thoughts from you. And the first one, which we like to ask our guests and even members of ACC and staff of ACC when they come on board, is what's your favorite national park or your favorite place in nature whenever you need to get away?
Oh, that's a great question. So I'm currently living in Portland, Oregon, and I love the Oregon coast.
Yeah.
So I would it would be heresy to pick one over any of the others. But I would also say last fall I had the opportunity to go to Joshua Tree National Park, and if folks haven't been there, it is definitely a bucket list experience. It's an amazing place. And among the national park system, it really is exceptionally well kept and cared for. So, you know, we we put a lot of wear and tear on our national parks, uh, but the folks at Joshua Tree really do a great job of keeping it as fresh looking as they possibly can.
And I agree with you. The Pacific Northwest, just in general, is such an awesome place to be. A cool vibe up there for sure. Book recommendation, whether it could be a classic you read a while ago or something interesting you read recently. What's something that you would tell our audience to go pick up?
Oh boy, um, wasn't ready for that one. Let me think for a moment. I just read Peter Zeehan's new book, and let's try to think for the title of it off the top of my head. But I've really been into the intersection of data and really getting into the numbers and math to help explain what's going on in the world right now.
Good.
And so, you know, what are the impacts of population increases? What are the impacts of a modernizing economy and its contributions to the global economy? Those kinds of intersections, and helping break down some of the things that we see and kind of flash by on the screen, and go a little bit deeper into understanding why that is. Um, that's that's something that's really been driving a lot of my reading, I think.
Awesome. Outside of the technology that Hydrostor is working on, what is a technology that you're most excited about coming online over the next couple of decades, or even maybe even beyond that?
You know, hydrogen has the potential to be a real game changer. Um, it'll be interesting to see how fast hydrogen can really scale up. Much like what we have with compressed air at Hydrostor, it's a known technology. It's proven already. You can separate hydrogen from water molecules and have a fuel that is clean burning, and that's a really interesting future that can be done at scale, and affordably. Right now, the big challenge is that it takes more energy to create that form of energy, and until you can get more efficiency brought into it, I think, its applications will be limited. But again, it's another case where, with some technology innovation, we can use a lot of the systems and workforces, and oftentimes many of the same communities can prosper under a hydrogen economy as they have under a traditional fossil fuel economy. So a lot of hope around the potential for hydrogen there.
For sure. And then our final rapid fire question here is, if you could put one message out into the world, it's a billboard that everyone sees, it's a Super Bowl commercial that everyone consumes. What is the one message that you would want to send to people right now?
Oh man, I think it really is kind of that golden rule message. We all know how we like to be treated. We all know what it feels like you know, to be welcomed and respected, and just making sure that that is how we approach every interaction that we have. I just think we live in a time where things are quickly inferred to their worst possible interpretation, and we seem kind of primed to take things in the most negative place. And I would really love to see a bit of a collective effort to de-escalate how we engage each other, because our time here is pretty short. So let's live it the best way we can.
Agreed with you there. And thank you so much for coming on the show. I think probably I certainly have learned a lot of new stuff today. Hopefully our audience has learned some new stuff, unless they are experts in compressed air and energy storage. But I think the case is that this is a really exciting technology that people are going to want to look into more. And so just want to thank you for coming on the show. I appreciate your time. Well, we'll end it on that note. I want to thank Scott for joining us today. Certainly, I've learned a lot. I'm sure you, the listener, have learned a lot, unless you came to this podcast an expert in energy storage and compressed air. But really informative episode. I encourage you to check out Hydrostor, and we thank them and Scott for being on the show today.
And before we jump, the Coming Clean podcast is grateful to be powered by Ørsted, a wonderful company strengthening America's energy security with reliable and domestic clean energy. Through its integrated renewable energy solutions, Ørsted is creating American jobs, investing in American communities, and driving American innovation, all while preserving our country's natural habitats. A clean energy future truly connects us all, and Ørsted is helping lead the charge. To learn more, visit us.orsted.com.